I'm sure most of this are known to you in C language. But let us see how it is different or how the Python handles it. So in Python, a function is an object. Okay. So when you declare def function some parameter colon something something, you can have a return or you can decide not to have a return. Then the function will execute up to this point and then come out. I'm sure you are all aware that the tab is what shows that the code is belonging to the function. I'm sure you know. So whatever is there is a function now. Now, when we declare a function, what happens is this is the label and this is the body of the function, and it accepts some parameter. Now, an object is created, which is a function object belonging to a basic type, some object type, and it is assigned to the label f1. So it is like f1 could be considered to be a variable. Okay, for our C language, we can say a variable or maybe a label or an identifier. You can call any of this, which is pointing at the function object. So this is like any other label that you have I equal to 2. Similar to that, this is also a label, an identifier, similar to any other f is equal to 2.0. Everything is pointing at some object. Similarly, even this function also is pointing at an object, which is a function object. So you can handle handle this as any variable holding an address to the function. These are all belonging to data, whereas this is part of a code. That's the only difference. It's a memory area, but this is a code area pointing at a code area, and this is pointing at a data area. Now you can actually assign it to some other variable. Then this becomes again a function object. I can invoke it with some number. So you can in fact pass a function object to as a parameter to another function. You can return a function object from a function, and you can store it. Of course, you have seen it in a list. You can store it and invoke it from there, function object. So you can handle the function as any other variable or a data and pass it across functions as a parameter and return from a function. All that you can do. Okay, that's how functions are defined in Python. Now what happens in C? C also does it. You have seen a function pointer, and then we say that it accepts integer, float, and returns maybe an integer. We need to declare a type as a function pointer in C. Then this can be assigned to the a function definition which matches with what you have defined it with. Suppose you have declared a variable called a function pointer. You must be knowing this left right rule in C to understand any declaration. If you need to understand a function pointer, maybe if you have a type def, then what you do, function pointer f1ptr with is a pointer and then parenthesis immediately following. Then is a function pointer is a pointer to a function accepting integer and float. You go to the right and then you go to the left, that returns integer. So you say that f1 pointer is a pointer to a function which accepts two parameters, integer and float, that returns an integer. So you can declare a function pointer in C and then assign a function which matches with this requirement. Then we will be able to call it with a parameter 2, 3.0 because integer and float. Then it will call this function and then it will return an integer when you are invoking it. Now this is a variable which is a pointer type pointing to a function object in C. Whereas this kind of a requirement is not there because it's in Python. You can declare a function and then that function name itself becomes a function pointer. Okay, similar to a function pointer in C, the label itself in Python is a function pointer, and we can pass it across. And you don't need to have all this very strict rules of what are the parameters and what are the return values. All that you don't need to do. Go declare, and the interpreter or a compiler takes care of resolving it when you are invoking it. Okay. Now, functions are first class object. We call it as a first class object which belongs to some in a language wherein those objects are handled uniformly across the language, across all locations or all usages, not locations, usages. It is handled in a similar manner. Okay, that is what is called a first class object, handled uniformly throughout the language, throughout the usage. Okay, you can pass a parameter, pass it as a parameter, return it as a value. You can do anything. You can store it in a variable. You can store a function in a variable. You can pass the function as a parameter to another function. You can return a function from a function. So you can return we don't call it as a function pointer. Please remember, in C, if you are referring to that, we will always say a function pointer of particular type of accepting some variables, parameters, and then returning something. Here we just say a function object. Okay, it can be passed across, and you can store them in a data structure such as a hash table or list or a dictionary, and you can invoke it anywhere, wherever you want. Now, a function definition is an executable statement. When you say def function and then colon, this is an executable statement, whatever you say. But when you are defining a function, that doesn't mean that it is getting executed. But interpreter will be going over it. Suppose if you are invoking the function, then interpreter will be going over it but doesn't execute it. But it will find out whether anything, any syntactical semantic errors are there, that will be captured or caught, but it will not execute it unless you specifically invoke it. So invoking a function is like this, then it will execute the function. Its execution binds the function name in the current local namespace to a function object. Now, when you say def something colon, this label is in the local namespace. Whatever is the namespace of this thing, this label is in that namespace. Now, what is the namespace? Namespace is the part of the program wherein a variable or a label is visible and it can be accessed. Okay, visible in the sense that when you are saying that F1 here, it knows that there is a function definition exists in this, and it understands it that it's a valid label, so it's a visible and it can be accessed or invoked. If it is a variable, maybe you may say that a equal to 2, then b equal to a plus 2. You can do it because it's visible as well as you can access it in a namespace. So when you are defining a function, it is associated with that local current namespace as a function object. So a function object is a wrapper around the executable code for the function. Okay, it's a wrapper around it, that object. This function object contains a reference to the current global namespace. Now, what is done is, when you have a definition in some place in a Python file, this, suppose if I am calling it as a.python, this Python file has a, whatever is the variable declared here is global namespace. Okay, according to this Python particular file. Now, this function which is present in this namespace is having access to these globals. This function has access to this global. That means this function object is passed a dictionary of the label and value. Okay, pair is a dictionary, globals is a dictionary which is passed to this function and which is available. Okay, globals. Okay, let me call it as globals. This is a dictionary which has the entries of all the variables which are visible here in the program. If suppose you have imported something, whatever it is, whatever is visible here, they are available to the function as a globals, and it will have a label and a associated value. So that's why it's called a dictionary. So that is passed on to the function. Okay, you can access it inside. So this function object contains a reference to the current global namespace as the global namespace to be used when the function is called. Okay, so it depends on where exactly this function is defined. If this is defined in this a.py, it will have its global namespace available. Suppose you have another function b.py and then you are defining a f1 here, then it will have its global namespace in the dictionary. So based on where exactly the function is residing, it will have its own dictionary passed on to it through the globals. You can access the variables which are there visible in the global namespace. We'll come to that with an example. We'll see. The function definition does not execute the function body. As I told you, the definition does not execute the function body. This gets executed only when the function is called. Okay, it is true with C also. There's nothing different. Now, global variables can be accessed from inside a function. Okay, but can also be modified only by using a global keyword. Okay, if you want to modify it, then you need to use a global dot something referring to the variable which is passed on as a part of a dictionary. Okay, so you can modify it using that. I will tell you with an example. Okay, how it is done. Built-in functions. This is globals is a built-in functions, returns a dictionary object of all global variables and their respective values that a function has access to. So this is what I was saying. This globals is a function which returns a dictionary which has all the references to labels of the global variables and their respective values that a function has access to. So if you want to know what all a function has access to, you need to call this function which will be returning a dictionary, and you will have all the entries. It's not only limited to your file, it has all the globals which are visible to it. If you have imported something, all that are accessible using this dictionary. Using the name of the variable as a key, its value can be accessed and modified. You can also refer it or modify it using this as a key. Okay, that we will see as an example. Now, argument passing. What is the difference between arguments and parameters? Okay, that these two are looks synonymous, but it depends on the usage. Now, this is when you are having a definition. These are all called parameters which are coming into the function. And when you are invoking a function using these values, x and y are the arguments to a function. So a subtle difference in the naming convention. Parameters are the variables listed inside the parenthesis in the function definition. Okay, what you see in a function definition is parameters. What you see in a function invocation is an argument. Arguments are the values that are sent to the function when it is called. Is a parameter passing in Python by value or reference? Normally this question comes, pass by value, pass by reference. But in Python, they say that it's passed by object reference. Okay, the reason is we call it as object reference because we really do not get the address where the object is residing, because we are not allowed to change anything in Python. like what you see in C. So here it's called object references because you cannot use it to modify some, some values you can change it, but you cannot be looking at the content of this reference. Okay, in C you can see the actual address where the particular object is residing, but here you get some ID, but it's still not very visible to the user. So that's why they call it as a pass by object reference. Here the called function creates a new variables in the local scope to refer to the object. Okay, so here what happens is this A and B are the two new labels. They point to the same object this X and Y we are referring to. So when you come inside, you have A which is also pointing at 10, and you know that 10 is an integer object which is there somewhere. So it creates a new label and then it points to the same variable. Okay, so the called function creates a new variables in the local scope. So A and B are visible only within the function, not outside. Like for loop, when you declare a inside, if you have a for loop in C, int I equal to 0, and then we say I less than 100 or 10, okay, I plus plus, then this I is visible only within the for loop, so it's not outside visible. So similarly, this A and B are visible only within the function. So local namespace, local scope. So local scope to refer to the object references being passed from the caller, by the caller, and the function could modify them. Now you can use it to change it or modify it based on what you want to do. When immutable object references like int, okay, when 10 and 20 are passed your function, the caller's variables passed as arguments would still continue to refer to the immutable object. So what I mean by that, this X and Y are also pointing at 10, this Y is pointing at 20, and A is also pointing at 10 and B is pointing at 20. So they are all objects references pointing out those immutable objects. But caller will see the changes to the mutable objects done by the called function. Now, if it is immutable, no issues. Suppose if you are passing a list, that is the major confusion that we normally have. Those who are going from C++ world, they think that I am passing by value by mistake. Then what happens is, if you are passing a list, okay, suppose instead of 10, X is a list, okay, some 10, 20, and then you pass it to a function, this value X, then if you append to this list, the caller also will see that it is appended because we are passing the reference to the list object into the function, and any changes done by the function will also be visible to the caller. Okay, it's that normally this is a common mistakes that we do in Python, thinking that those is not change, whatever changes happening in a function will not affect the caller, but that's not true. Okay, that you need to keep in mind. If it is a mutable object, yes, no problem, but if it is a immutable object, but if it is mutable, then you will have a problem. Now, what are the namespaces and scopes? Okay, since Python is dynamically typed language, variables in Python come into existence when you first assign them a value. This you are aware already. Whenever we declare something, that's a safety measure here, that you cannot have any uninitialized variable in Python, whereas you can have a local variable int I in C, which will never be initialized, and you can even use it without knowing. But some compilers are intelligent enough to say that it is uninitialized, but some compilers will still allow you. So those kind of issues are not there even in Python, that any variable gets a existence or becomes alive only you assign some value to and then associate it with a label. Okay, on the other hand, function and classes are available after you define them. Okay, here you declare a variable, but you assign you don't declare it, actually you define a variable and then you assign some value also to it, then it becomes alive. Whereas function objects, as I mentioned, they are not even invoked, they are not even called even once, but this object is alive. Okay, it's there, it can be invoked, but it's not that you need to call it to make it alive, it will be there. So other hand, functions and classes, we'll come to the classes later on, available after you define them using def or a class respectively. There is an important difference between assignment operations and a reference or access operations with a global variable. Okay, I will talk about global, then we will know. Okay, keyword. I think this till that point, do not worry about it. A namespace is a dictionary. Okay, mapping names to a string. So I told you that all the globals are associated with a function globals, which returns a dictionary. Okay, which has the label to value association. Okay, so any namespace is a dictionary inside a Python, which are nothing but a names to values, mapping from names to values. When you refer a variable, Python looks through a list of namespaces. Now, what happens is when you have a function definition, okay, and then you are calling a equal to something b plus c. Now, when you are using b, what does it do? Python, it is looking for this label in some order. It will first do in a local namespace. Now local namespace is nothing but some dictionary. It will look for this b and this c also in the local namespace. If it doesn't find it, then it goes to the next namespace. I'll come to that. There is one more namespace before we go to global. Okay, so and then module level. So any label or function, if you are calling a print function from here, now print is a label, again a function object. This print function is not defined here in a local namespace, and then we are not defining it in a global namespace also. Then it goes out to look for the module level or the outermost level, wherein this print is defined as in some library where you have built-in library functions. Then it gets resolved there. So any label, the search happens from innermost to the outermost namespaces, and each of the namespaces are nothing but dictionaries having association between a label and a value. Value is nothing but either if it is a normal data, it will be a value. If it is a function object, it will be the executable code which is defining the function object. So this is how, when you call a print, the resolution of how to invoke the print happens from inside out. Okay, so when you refer a variable or a function name, Python looks through a list of namespaces. When you say Python, it's an interpreter which is doing the searching, looks through a list of namespaces, or maybe compiler, because even before the interpreter, compiler should have created the bytecode, so it should have resolved all these issues. So actually the compiler takes care of that and generates the bytecode, then the interpreter executes it. So it's at the compile time this happens. It goes through the list of namespaces to try and find out one with a name as a key to get the value stored in it. Okay, whatever value, if it is a data, it will be a value. A scope defines which namespaces will be looked in and what order. Okay, a namespace says which namespace will be looked in and what order. Okay, we will look at different namespaces now shortly. So the scope of any reference always starts in the local namespace. Reference means accessing it. It always starts as local namespace and moves outwards until it reaches the module's global namespace. Okay, before moving on to built-ins. So this is what I said. This is a module's namespace means a.py. A single file is a module. So it starts off from the function, inside of the function, then it comes to the global namespace. Okay, and module is a function. Then if it is not there, then it goes out to the built-ins if it is available in built-in. Now inside a.py, if you have imported some module, then they also become part of it. So they will search through all of them before going to the built-in. Okay, so if you want, you can override the print with your own print, then the search will stop. Suppose if you have defined a print function inside, then it will not go and call the library function print. It will call you whatever print you have made it. So you can avoid calling this print. Okay, is any built-in function you can avoid it. It's like shadowing the label, which is a built-in function. Whenever a new function is defined, a new namespace and a new scope are created. So when you define a function, within the function definition, a new namespace is created. That is called a local namespace. Okay. If it is only one function, if you have an inner function, then there will be one more namespace which will come in. So now different levels of scope. This is the local scope which is within the function. There is a enclosing scope, okay, which is if you have a function, you are free to define another function within it, okay, inner function. Then now this function definition is inside this function definition. So this inner function is not visible outside. If you want to call, you can call this function, but that doesn't mean that this will be executed. See, it's like a definition, function definition. If you want to really execute this function, you need to call inner function here, okay, somewhere in one of the statements here. It only defines it and it retains this inside this function scope. Okay, now there are two scopes now with this function. This, if I call it as outer function, it has got its own space, and then inside that there is one more function scope here. So whenever you define a function, there is a new scope getting created, and this inside this function, what you see here, there is something, maybe if you have defined some variables here, they are called enclosing scope, which is this function is enclosing the inner function. So whatever variables are there, they are not falling under global namespace. Global namespace are here. This is something which is inside the function. Okay, let me show it in a different color. So these are all variables which are there between this function definition and this definition. This is not called global namespace. This is called enclosing scope. And what is here is a global, okay, anything outside the function. This is a function inside a function. This is called enclosing scope. We will come to the inner function maybe in more detail with the examples in the next class. Here, this is only a very high level introduction to different scopes and namespaces and how it is internally managed by the Python. I'm trying to show you. The scope of a variable is that part of the code where it is visible. Okay, that's what is called scope. A variable is a part of the code where it is visible. No need to use any prefixes to refer to it if a variable is visible. We don't need to qualify it with some global or something if it is visible in the namespace. Okay, then you can directly access that label. Lifetime of a variable is the duration for which a variable is alive. So a lifetime is similar to C function lifetime. We say that inside a C function, the variables are, local variables are alive as long as you are inside the function. Once you exit from this, the local variables are gone. The locations reserved for them are gone. They are in the stack. That's what we learn in C. Here, there's a similar logic is there, but it's handled in a different way. And any variables that you declare inside a function is visible only within the function. It's not visible outside, or they are alive outside. Okay, it is only alive within the namespace, within the scope. Local scope, the variables here are alive only when a function is executing. Similar to C, whatever is are the variables which are in the local scope, they are alive only when a function is executing. Enclosing scope, which is what I mentioned, a outer function which is having a another definition, inner function, and something is there, and you have in this scope you have something. Now if you have any variables here, they are non-local. Okay, they are they are not local to this variable, this function. Their another name is non-local, which is in the enclosing scope. Okay, this falls under this scope, falls under enclosing scope. Okay, which is outside of local scope, outer layer of local scope. So this enclosing scope may be there, may not be there. If you do not have an inner function, then this is not there. So directly you will come from local scope to global scope. If there is an inner function, then you have an enclosing scope. Okay, and built-in is the outermost one. All the print and length, all those functions are all falling under built-in scope. So the variables and functions defined in the outer functions, which are called non-local. Inner functions, function defined inside another function is called inner function or nested function. Okay, another name is like a nested dictionary. This is called nested function. Okay. Enclosing scope is the scope of variables or functions in the outer or enclosing function. So you call it as outer because it is outside this local scope, but it is in between the global and local scope. Global scope is variables and functions defined within a module in a Python file. Okay, within a Python file, we call a Python file as a module, and those variables and functions defined them fall under global scope, which are available in the dictionary, which will be returned by globals function. Okay, this dictionary will have all the entries which have all the variables and functions defined in the global scope. So remember, even the functions are found in the dictionary. Why? Because they are also labels or objects. So functions are also objects. So you will have a label and the value will be the function object, which is in the code area of the function. Okay, the Python program. Built-in scope, the variables and functions defined by Python. Okay, all print and other things. Both functions and variables in global and built-in scopes live till the program ends. So now, whatever variables are there in globals and built-in scope, they are like static variable in our C world. So they live till the program ends. Okay, they are alive. Okay, their life is till they are the program till the program ends. This is what is called LEGB rule. Okay, maybe in the interviews, if they call you, do you know LEGB? Then you can say local scope, enclosing scope, global scope, and built-in scope. So this, in a short form, they call it as LEGB. So this is what I wanted to cover as a theory portion. Any questions from anyone? So far? Okay. So let us, we have some 10 minutes. Let us write simple function. Now let me call some G int to G float G string. Okay. Now definition function print G global vars G int G float GSTR. Now what has happened? The function is defined but not invoked, and already there is a label which is created and associated with this function definition. Everything is ready now. Now I have to call this, sorry. So I can access it internally. Now what happens is, it first find out these labels are there in the local namespace. If it is not there, it goes to the global. Now I can shadow that similar to see what you do. Now what happens? You get 3 because G int is resolved in the local namespace. That's how I say that it goes from inner to outer, looks for the dictionary that is maintained for the local dictionary, okay, and then if it is not found, it goes to the global dictionary, the namespace dictionary, and this is what is happening. Now what if I want to do, now line number 9, reference before assignment. Now let us try to understand this thing. Local variable G float assigned to but never used. Okay. Now you see this one. It is when you are doing it, the label, it assumes that you are creating a new label and it doesn't refer to this. Okay. You are not actually writing into this label. It is assuming that you are creating a new label here and assigning a value of 200 here. So you are in fact, like what you did here, you are shadowing the global variable by this. Now if I want, actually if I am, my intent is to really access the global, then I need to do now what happens, let me print now let me explain. What did we do here? We said that this G float, when you are trying to assign a value to 200, do not create a new label. I am referring to the label which is in the global namespace, which is there. So I am just giving an indication to the compiler that this G float refers to the global variable. So when I print here, this is visible, this G float only is visible here. What if you are declared any global variable, any variable here in the local namespace, it won't be visible here. But how did it get 200? Because I call the function and then I assign this 200 here inside it. Now suppose if I don't call this function at all, what will I be getting in G float? I will still get the old value 2.0 because this was not executed at all. So this assignment has not been acted upon. So if I execute it, then it is executing it, and now I am telling the compiler that this G float is a global variable, similar to what you do in C, global variable access, and then whatever assignment you are doing, it refers to this, and that's why you see that when you run this, you get 200 accessing it. Now how is it happening? It is, if you are not mentioned this, then this will be shadowing this and it will create a new label with a new value, and when you print here, it will only print this value. Okay, if you don't have this. So this is one way of accessing it. I will also tell you in some other means of accessing this variable. Now suppose I want to access it. What do I do? G dictionary equal to globals. I said that globals function returns a dictionary which has all the references and the values of all the global namespace labels. Now, how do I access it? I am using the dictionary as a normal dictionary, and I use a label which is gfloat now equal to 300. Okay. Now, what am I doing? I am again assigning wherever this label is pointing at, that label, I am now making it 300. Maybe I should not change it because I'm calling it as a float. So let me not follow some convention. Okay. Now, what do I get? I get 300 here. How did I access it? I access it here with this. Now, to make this work, I need this. But to make this work, I don't need this. So let me, okay, let me first don't override this. So let me copy this. Maybe, what is the time we have? Okay, another 5 minutes. So let me write it again. Now, let me remove this, remove it. Now, I don't need that global definition now. Now I am calling this function again. Maybe I should make it 400 here. Let it look different. What is happening? Okay, I am printing it out inside. Okay, I am printing it here, which will be the old value 300. So I need to print it here to really get this 400 to be reflected. Now you see, for doing this, I don't need to have any other declaration because default this dictionary is passed to the function. It is available to the function. So it is like when your function is executing in an environment, it gets all your path variables and environment variables are passed to the Python file. We have seen that some time back. Similarly, in C, we get parameters getting passed, environment variables are getting passed as an array. Similar to that, in a function in Python, apart from whatever parameters you are passing, it is implicitly getting all the global namespace variable association or label association as a dictionary into the function. Okay. In C, sorry, you get this pointer into the function, which is implicit, which is not visible to you. Similarly, here, when a function is there, the globals coming in is not visible. Okay. So if you want to use it, you can use the globals and dictionary. You can get the dictionary. Now you have an access to the dictionary, and if you know a global variable or label which is available visible, you can access it inside them. So it's not only for this, you can also do for any other namespace which are there. Okay, you can put int which will modify our g int is there, so that I can make it 4. Then I will have print g int which will reflect the value. Okay, you can do any other things here. Okay, any questions from anyone? I hope it is clear. I will not go further. I think it is enough today. I will start with more things about functions in the next class. I will let you go. Have 10 minutes of break before you take a next class. Any questions from anyone? Final call? No. Okay, no problem. Okay, I will stop here if there are no questions. At least I hope whatever I explained was clear. Should I take a poll? I don't think so. Okay, anyway, I will take a poll. Once again. Uh, okay. Um, I just want to have a global view of how things are going. I have never asked you. Maybe I will use this couple of minutes for that. Um, I want to just ask you one question, that whether you find this way of teaching, the way I am explaining, is it easy, difficult, is it comprehensible? So if it is so, you can raise your hand. If it is not very easy to follow or difficult, or I need to change, I will ask you another uh, poll I will do immediately. But right now, the poll is open for raising the hand for that you are following me so long, so far, without any problem. Can you please uh, raise your hands so that I know how many of you are with me? Okay, majority, except. Don't worry, I am not going to catch you and then say, pull you out and then say, why didn't you raise your hands? If you are not following me, please feel free to do that. So I see that Mohit, Shivangi, and Shivani and Jasmeet don't feel that they are following me. So maybe I will. You can tell me here what is that I need to do differently so that you find it easy, or what is the, you can tell me in case if you want to tell me anything now. I'm not singling you out, so don't think that I am just cornering you. But you can always, yeah, go ahead. Anybody? I'm not asking about those who raise the hands, but somebody, Mohit or someone wants to say, or they are away from the machine. I don't know. Possibility that they are away. In case if they are not replying, oh, Shivani is come back. Okay, no problem. In case if you feel that this is not the forum to say the issue that you have, um, it is quite possible that Python is totally new to you, and I may be uh, going fast. There's nothing wrong. Okay, please feel free to tell me. Okay, I think Mohit also now come back. Okay, Manish and I think Manish raised a hand already. Okay, oh, Shivangi, everybody is there. Okay, no problem. Uh, I'm happy that you are following me. In case if you feel that it is too slow, please tell me. I can go fast. Or if you feel that, okay, let me ask you one more question before I close that thing. Um, do you want me to maintain the same speed, same pace of covering the topics, or you want me to go faster? Okay, because you are all following me now, so I will not ask you whether I want to go slow. So I want to ask you one question. You can keep it raised if you think that the pace is okay. Okay, uh, okay, pace is fine, so I don't want me to go faster. Okay, so I will not hold you back. Thanks for your feedback, and feel free to always send me a mail whatever you like or don't like in my course. My intent is everybody should follow this course, and every one of you should become good in Python, because you are coming to, for good reasons, you are coming to data science and AI, and you need to be good in Python whether you like it or not. Please spend time and become a good Python coder better than me. Okay, I want you to be all in 1 year down the line. You should be better than me in coding in Python. Okay, that I will be very happy to hear. Okay, so thank you very much. Thanks a lot, and see you next week. And have a nice weekend. Enjoy. Bye bye. Good night. Thank you. Thank you. Bye bye. Good night.